All right, let's say John drives to Billings. Okay, well, if John drives to Billings, he will use 15 gallons of gas. If John uses 15 gallons of gas, then he will spend $48.35. So those are our statements. John uses 10 gallons of gas. Which of these statements below do we know to be valid? Well, let's form our conclusion first. So let's look at our if-then statements up here and form our conclusion. Okay, if John drives to Billings, he uses 15 gallons, and if he uses 15 gallons, he'll spend $48.35. What would our conclusion say? Well, we put the two statements together. Okay, the first part, take out the middle that's repeated, the 15 gallons. So our if John drives to Billings, then what? What happens? He will spend $48.35. Okay, so this is our conclusion. This is what we know using the law of syllogism. If he drives to Billings, he's going to spend $48.35. Then they tell us, well, John used 10 gallons of gas. What can we conclude? Well, from this statement, nothing, because we were told if he drives to Billings, he spends $48.35. After that, we know nothing else. Okay, so what can we say? Can we say he spent $32.23? Well, you might try that one. You might say, oh, 15 gallons of gas, that was $48.35. So 10 gallons of gas, and if you calculate it, you do come to $32.23. However, they didn't say that he just spent the money on gas. Maybe he bought a candy bar and a pop. Okay, we cannot conclude that he spent $32.23. We can't conclude that he spent $40. We know nothing about that. We can't conclude that he drove to Red Lodge just because he used 10 gallons of gas. The only thing we can conclude here is that John did not drive to Billings. Okay? If he drives to Billings, he's going to use 15 gallons of gas, and he uses 15, he's going to spend $48.35. So him using 10 gallons of gas, the only thing we know for sure is that he did not drive to Billings. All right, deductive reasoning can come in handy for solving puzzles. Okay. In this puzzle, each letter represents a different digit. What does the D represent? Okay, so on your puzzle in your project, it will look a little different, but we'll go through this one to help you try and figure out the other project, the one that they give you. So looking at this, these are single digits. So this is the number either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Which of those numbers, when you multiply it by itself, does it equal itself? So one thing you can do is just trial and error. Try it out. What is 1 times 1? What is 2 times 2? What is 3 times 3? What is 4 times 4? Which of those numbers equals itself when you multiply it? Well, we know that 1 times 1 equals 1. So that means that our D must be 1. 2 times 2 is 4. Okay, that's not going to work. 3 times 3 is 9. 1 times 1 is the only number that when you multiply it by itself, you get the number itself. So for this one, I know that our D must be 1. Okay, hang on to that fact as we go to the next question. In this same puzzle, what is V going to represent? So what do we know so far? So far we know that our D is 1. Okay, so far on our last question we decided that 1 times 1 equals 1. 1 is the only number that does that. So our D has to be 1. Well, if D is 1, what does that make V? If we come down here and we know D is 1, so we replace this with a 1, and we replace this with a 1, what does V have to be? Well, 1 plus 1 is? I hope you said 2. Okay, so knowing that, whoops, sorry about that. Knowing that D was 1 helped us to solve the fact that this 1 plus 1 would make V 2. So we know that V is 2. Okay, so we're continuing to solve the puzzle. The only one other number we have to find out is P. Okay, so again, what do we know so far? We know our D's are 1s. Okay, D is 1. We're kind of decoding this as we go. And our V is 2. When we get down here to the bottom, we have a number P. P plus P plus P equals DP. Again, these are each single digit, so P is a number 0 through 9. Okay, D, what is D? We know what D is, right? It's 1. So what we're trying to find here is a number that when we add it to itself 3 times, the answer is 1 and then the number, that same number. Well, let's try out a couple of numbers. Let's try out 2 and see if that happens. What is 2 plus 2 plus 2? 2 plus 2 plus 2 is 8. That's not going to work. Not only did we not get a 2 here, we didn't even get 2 digits. We need a 1 followed by another number. So let's try out another number. Let's try 3. 3 plus 3 plus 3 is 9. Again, that's a problem because not only do we not have the 1 in the front like we needed, we don't have 2 digits on that. Let's try 4. 4 plus 4, and maybe you found the number already, maybe you're still following along with me. Either way, we'll keep plugging along. 4 plus 4 plus 4 is 12. Okay, all right, what do we got here? Well, we have 2 digits now, but our problem is this would have to be a 1, 4. Notice the second digit is supposed to be the same number as the numbers we added together. So 4 also does not work. It gives us 2 digits with a 1 in front. It doesn't give us the 4 on the end that we needed. Let's try 5. 5 plus 5 plus 5 equals 15. Hey, that works. Notice we have the same number added 3 times. That gives us a 1 on the front and that same number again. So P for this problem would have to be 5. Okay, so the purpose of this one was they just wanted you to use logic to work through a problem.